Welcome to 3 cool things you can do if you have a big histology dataset. This research was carried out as a joint work of the Institute of Neuropathology at the Free University of Berlin and the Pattern Recognition Lab of Friedrich-Alexander-Universität Erlangen-Nürnberg. What you see here in this picture is a histology database. It contains lots and lots of slides of specimen. However, it's an analog histology database, which is a bit bogglesome for us, since we want to use the data to work on it. However, one of the big challenges that we have is that once those images are digital, they are really, really big. In this example, the image has some 74,000 pixels in height and 114,000 pixels in width. If you multiply this as typically done for digital cameras, you end up with 8.4 gigapixels. That's a lot, isn't it? As you can see, those images contain lots and lots and lots of details. Now we're finally at the maximum zoom, and at this zoom level, the experts will be able to differentiate all the cells. And they will be looking for special cells. Our work focused on mitotic figures. Mitotic figures are cells undergoing cell division, and they are an important factor in tumor grading. Did you spot it? This, for example, is a mitotic figure. While a pathology expert will be able to identify those in this maximum zoom level, it is impossible when you zoomed out completely. Many current datasets are limited with their annotations on this kind of red rectangle. The area you see is called a 10 high power field area. However, the question arises, what is going on in the rest of the slide? And further, the question arises if we now take those annotations, put them into a machine learning system that we train with it, and then feed it to the complete image. I can tell you, this does not work very well. Now, what we need to have is a big dataset with complete annotations over the whole image. And this is what we achieved just lately. You can find all the details in our publication in Scientific Data. But wait, there's a couple of more images. In total, we annotated 32 images. Having this big database, we can now go on with our list of 3 cool things you can do if you have such a dataset. First, we can do a detection of mitotic figures. That's obvious, isn't it? So, we start our software and we enable the plugin where we have the machine learning in the background. And this is how it looks. As you can see, we have lots and lots of detections on this whole slide image. As you can see, there are 2 colors. We will only be discussing the dark green ones now, which are the real detections. Second, we can do a heat map of those mitotic figures. For grading, it is important to count wherever there are the most mitotic figures. So this is an important step in computer-aided diagnosis. So, quite similar to what we just saw, we can integrate over the area of 10 high power fields and display this as a heat map. Wherever we have the hotspots, we will also have the most mitotic figures. Finally, let's come to number 3. We can additionally also propose an area to do the manual mitotic count. With this, we aim to reduce the known high inter-rater disagreement. As you can see here, we now have this black rectangle. It's actually not only one rectangle, but it's a grid that can conveniently be used in order to facilitate counting. If we zoom in a little, we will find lots and lots of detections by our model. The expert can now go through the 10 high power fields and see to which mitotic figure detection he or she agrees or not. That's it. Thanks for watching.